Hey, what's up, Team Trilogy? Jeff Hessler here, Maintenance Operation Manager, and thanks for joining me. Today, we will be covering troubleshooting for air conditioning season along with parts identification as we troubleshoot. So, with all the moving parts and possibilities of what can go wrong, no wonder it's so hard to figure out where to start. So I reached out to all of our very knowledgeable, wonderful supervisors and came up with best practices on where to start. So if you have the luxury to start at the condenser, start there. It gives us clues if the problem is inside or if it's at the unit itself, just by walking up to it. So what do I check for? We want to check to see if the condenser is running. Is there line set? Is it frozen? Is there ice on the line set? Is the compressor running but the fan is not? Is the fan running but the compressor is not? You check the line set. The line set, is it cold? Is it sweating? Is the system pulling heat off the top? These are great visuals just walking up to the unit itself to kind of get us started before we head into the inside. So once we're on the inside, check the thermostat. Is the thermostat blank? Is the thermostat set to cooling? Is the set temperature lower than the actual temperature? Meaning, if it's 72 degrees set temperature and it's 73 inside the apartment, the thermostat should be kicking on and we should be cooling. Now, if it's 72 and its set temperature is 74, of course it's not cooling because that set temperature is not lower. If the thermostat is on and it's set to cooling and it's still not coming on, go ahead and take the batteries out if they have batteries in them and plug it back in to see if the thermostat comes on. If it goes off, we have something that's wrong on the inside. We do not have power to the thermostat itself. So while we talk about the thermostat, let's make sure that that thermostat is wired properly. Our white is going to be our heat. Our yellow is our air conditioner. Green is for the fan. Red is a constant 24. Blue is our common. Orange is for reversing valve and cooling mode on a heat pump application. So let's check the furnace. Is the furnace fan running? Does the furnace have a door switch? A lot of these panels will have a door switch, and if it's not engaged, your furnace simply won't come on. So if our furnace is not coming on, again, check that thermostat to see if the system is on. It's a quick and easy problem that will be overlooked, so double check, make sure your air conditioner is coming on. Is the breaker tripped? Check and make sure the breaker isn't tripped and we have 240 volts coming in. Is the fuse blown? Make sure the fuse is not blown. If it's blowing, check your low voltage wire. Chances are they're touching and that's creating that blown fuse. Is this transformer working properly? If we have 240 volts, we may need to testify the transformer to make sure it's sending the correct voltage to the fan control board. To test that, simply put your leads on the common and the 230 terminal when you ground yourself out. Is there a float switch? A float switch will interrupt the system and make it look like there's no power. So let's identify what we have going on in here. We have our electric heat strips. We have this purple disc right here. This is, good Lord, this is a heat strip. This is a heat limit right here. It's a limit switch. I'm sorry. It's a limit up to about 150 degrees. We'll cover those when we do heating mode. This is our fan control board. This is our fan motor inside the squirrel cage. This is our fan capacitor. It kicks the motor on, gives it extra little power to kick on. This is our evaporator coil, the slanted evaporator coil. This is your TXV valve, thermal expansion valve. That is the metering device. This is a slanted evaporator coil. This is the low side port. This is the high side port. This is the orifice with a piston. We will be charging this with superheat. This is a slanted evaporator coil again. And this is your thermal expansion valve, the TXV valve. We were going to charge this system. We would charge that as subcooling. This is a sequence. The sequence turns components on at the right time. It activates each phase of operation of the air handler, electric strips, fan motor in a sequence. Our transformer raises or lowers voltage to meet components' needs. 240 comes in, it then breaks it down to 120 or 24 volts, again, whatever components need. Our fan control board, it communicates with the fan motors. High speed, medium speed, low speeds, that is the job of the fan control board. Our blower fan capacitor, again, it adds the power to get the fan motor started. Our float switch. The float switch will shut down the power to the unit to prevent water from leaking. It's plumbed into the condensation drain to detect water. It's wired on the inside of the furnace to the red 24-volt thermostat wire. So if it senses water, it just shuts down your furnace. Frozen line set. So if we have a frozen line set, immediately pull the disconnect. We want to shut the unit off. Now, are both indoors and outdoor fans running? Is the filter dirty? Is the evaporator and condenser coils clean? Is the system low on charge? Now the unit's necessarily low, not low on freon. If there's poor to no airflow, the unit will freeze up. So you always want to make sure if the fans are running, the coils are clean, before we want to throw our gauges on that. So if we have a frozen line set, before we can hook up our gauges, that system will need to thaw out before we can get an accurate reading of our pressure. We also want to let our system run for about 10 minutes to regulate. So, is our suction line below 30 degrees? 30 degrees saturated temperature will be this inner one in here if we have R22, so it's the inner ring. If you're below 30 degrees, the unit is low on charge and it will probably freeze up pretty quickly. Is the head pressure too high? So this is the high side pressure. If that's too high, we may have a dirty filter. The coils could be dirty. That's usually an indicator of high head pressure. Now, is the pressure bouncing? A lot of times if you see that your high side or your low side, if these are bouncing back and forth, chances are you have a restriction on the line set where we would need to recover the refrigerant, replace the filter dryer, pull the vacuum, and then recharge the unit. These are our service valves. This is the high side service port, high side king valve, and the service valve. These are called a lot of different things, depending on geographic where you live. I think that's the biggest component. This is a service port. This is on heat pump applications. Low side king valve, low side service port. Outside those service ports, we have the Schrader valves. This allows us to pressure test. This prevents refrigerant from leaking, but this also is one of the main culprits for leaking refrigerant. So we always want to put on our caps back on those service ports when we're done reading our gauges or hooking up our gauges, we always want to make sure we have caps on there to reduce the risk of refrigerant loss. Our filter dryers, this is a bi-directional filter dryer. This is for a heat pump application. It will flow through both sides. This is a liquid line filter dryer. This is for condenser only. You see the flow that goes towards the house, so towards the indoor. Always make sure the arrow is towards the indoor. So if our condenser is not coming on. Now, before we remove the panel on an air conditioner, make sure you pull the disconnect to prevent shock. Now, is the contactor, is it sucked in? Do we have that 24 volts? If we need to test using a voltage meter on VAC, check the yellow and red thermostat wires for 24 volts. Is there voltage to the contactor? We need to have 120 volts on the black and the white leg with a total of 240 volts to run the condenser. So make sure the breaker on the inside is on. Is the capacitor, is it good? If the compressor is working and the fan is not, or vice versa, chances are it's the capacitor. Now, does your system have a pressure sensor? If so, we want to make sure there's pressure in the system. If there's no system pressure, it won't kick on because of that sensor. So you always want to double check on that. So this is the inside of the heat pump cabinet. The only difference between this and a condenser is not going to have this board. This board is the defrost control board. We have our capacitor. We have our contactor. This is our 24 volt line that comes in from the furnace up to the defrost control board. Our 240 volts, they come in right here, line 1, line 2. It's 120 on one leg, 120 on the other. The defrost control board. It defrosts the coils on heat pumps, on heat pump mode, in the heat mode. Only in the winter will you use this defrost control board. Our contactor, it sends voltage to other components. It controls 24 volts as well as sends power to the compressor and fan motor. So it pulls in that 120, 240 volts total, and then it just breaks it down and sends it to the components. Our capacitor. Now, again, if the compressor doesn't kick on or the fan doesn't kick on, chances are it's a simple capacitor, and it sends extra power to the compressor and the fan for the startup. So this is a very common problem that we have that you see a lot. I probably go through 10 to 15 a season of these capacitors, a very common problem. So if the compressor is not coming on, do we have voltage from the contactor? We want to make sure that we have 240 volts coming from the contactor. Is the capacitor working properly? Again, that capacitor is a problem. So check the capacitor. Make sure you're getting the correct microfarads. If it's a 35 by 5, you need 35% for the compressor, 5% for the fan. Is the pressure in the system? Again, you have a pressure switch. You want to make sure we have pressure in the system. If you have the correct voltage, the 24 and the 240 voltage, and the compressor is still not kicking on, or the fan is still not kicking on, try using a hard start. Now, if you're going to use a hard start, remember, you can only keep those on there for 48 to 72 hours. It is not permanent. We want to take those off. They can start a fire. So this is the inside of the heat pump. This is our defrost strip, the defrost switch. Our pressure switch, that's the pressure switch that I was just talking about that won't allow the compressor to kick on. This is on heat pump mode applications. This is the reversing valve. We have a filter dryer. The accumulator holds store refrigerant so it doesn't flood the compressor. Our compressor, the heart of the system. And our coils. That's inside of the heat pump. Thanks for attending today's troubleshooting. If you guys would like more info, or you have any questions, please reach out to me. You can email me, call me. I'd love to help. Thanks, guys. Have a great day.